Okay, so we're back talking about section 1.8, and the last thing we had to address in the absolute value situations is the special cases. So if you'll look with me on example 4 in your book, we will see, and we kind of saw this a little earlier in the last video, but what to do with a negative. What if you've isolated your absolute value sign, so there's nothing multiplied in front of it? We haven't really seen any examples like that, but it could happen. I just want you to know, if you have any multipliers or anything added or subtracted, anything around your absolute value sign, outside of that, you want to isolate it, move it to the other side with our algebra rules. But once you've just got an absolute value sign, and then one of our inequality symbols and a negative, that's going to be your special case. If it just says it's an absolute equal to a negative, just put in no solution. We never have an absolute value answer that will equal a negative, so that's definitely a special case. But here's some other ones with the inequality. What about absolute value being greater than or equal to a negative? Wouldn't absolute value always be positive? This output's always going to be positive. So a positive number is always going to be greater than a negative number. So if you have an absolute greater than negative, that's an always true, or for any real number from negative infinity to positive infinity. And you might try some numbers just to see this for yourself. If you plug in, say, 1 for x, or if you plug in 7, or a million, or negative a million, whatever number hits your mind, if we plug that in for x, it's going to work. So let's try a number like 1. This first thing that comes to mind. 2 minus 5 times 1 would be 2 minus 5, or negative 3. But when we take its absolute value signs, it's positive 3. So it's always a positive when we're done with this work, whatever we plug in, which will be greater than a negative. So always true. Now on the flip side of that, what if we had an absolute less than a negative number? Again, it has to be isolated before you make the determination, but it's still a negative number here. Well, whatever you plug in for x, the absolute value signs is going to make this side positive. So a positive is never going to be less than a negative. So that's never true. That's a no solution. It can never be less than a negative nor equal to a negative. That's just never going to happen. So no solution there. And then lastly, this special case, what if it's equal to 0? Now, can absolute value equal 0? It can. It just can't be a negative number, but it can actually equal 0. There's not a positive and a negative of 0, the two answers we normally have. But certainly, what could we plug in for x that makes this side 0? You might kind of see that. If I plug in negative 3 times 5 is negative 15 plus 15 makes a 0, and the absolute value of 0 is 0. It's saying, how far is 0 from 0? Well, it's 0. It's no place from 0. But to work it, you just do the one problem then. You know, if you've got an absolute equal to 0, you just set your quantity equal to 0. So what makes this equal 0? And there'll just be the one answer. And that's where I got the negative 3. You could solve that to see negative 3 is the answer. Just one answer on that. All right, hope that helps.